So I said that to any angle, it could also be -7 or 10, right? You get a number from out of any of these functions, because having a number which is bigger than something between 0 and 2 pi, we just, if it's negative, we just go backwards a sufficient amount of times, or if it's 10, right, then we should go one forward, one round forward, then we get to 2 pi, which is a bit more than 6, then pi, that's 3 pi, that's a bit more than 9, and then a bit down, then we get a point here, right? So it makes sense to have sine and cosine and tangent and cotangent and secant and cosecant, even of numbers that are not between 0 and 2 pi. And as you can see here, if I move, so this number that you see down here is 1.51 radians, right? So if I go to 0 radians, you will see that I start out here, right? Then if I move in the positive direction, my point moves upwards, right? My point on the unit circle and if you project the point here to the x-axis, no, the y-axis, you get y-coordinate of the point, and that is by definition sine. So if we plot the value of sine as a function of radians, note that I have used units down here that makes this pi. I mean, there's no 1. There should be a 1 here. But if you write pi's and 2 pi's and 3 pi and so on down here, you sort of see that there's a nice symmetry in this function, right? So you can do like this. What does cosine look like? Well, it looks like this. It's the same thing, only you take this point and then you project onto the x-axis, and then you get the x-coordinate of the point. And then you get a function like this. So given any angle, you get a point on the unit circle, take the x-coordinate of that point, and you get the value of this function. Tangent, now things start becoming more complicated to look at. So what do we have? We have a point on the unit circle. You make a line going through the origo, through the point, and hitting this line given by x equals 1. And the height of this crossing point, so the y-coordinate, is the function value alpha of tangent of the angle alpha, right? So this is what you get here. Cotangent, same story, only the line that this line should, or the crossing point between the two lines is between the line we had before and then this line here, which has equation y equals 1. So you get something like this, right? Or my function value, my parameter is going negative, right? But it doesn't matter. So you can see that the tangent and the cotangent functions are very similar. One is decreasing on these subintervals, the other one is increasing. Sine and cosine were also very similar. One is just, in fact, a copy of the other, shifted by pi half. Then we also had the secant function. Here it wasn't the crossing point, but the length of this piece of line, right, that gave us the value. So the secant will always have a distance to, I mean, the graph of the function will also have will always have a distance at least equal to 1, but that's obvious, right? Because this line here will always have length at least 1, right? So this is the graph of the function that depicts the length of this line as a function of the angle, right? And similarly for the cosecant, again, it's just a shifted version of the secant, and it looks like this. And you can note, by the way, that how do you get a negative length? Well, you get a negative length if this line You have to go in the opposite direction, so to speak, from this point. Then we just define this length to be negative. So this length here is negative, right?